In this session, we're beginning a series of implementing our UML in a formal computer language. The language of choice for this series is PowerShell. I have other videos on getting started with PowerShell, and the reason I choose it for this series is that PowerShell is automatically installed on Windows machines. I'm assuming most people are coming here with from a Windows platform. And again, it's just automatically available. You don't have to install things or get tools and set anything up. The other thing is that PowerShell understands .NET. So the same libraries that would be used in C# are available to us in PowerShell. And finally, PowerShell, the syntax is relatively easy and straightforward. It's also an interpreted language. So again, that's going to make it easier for us to get in and try things, as you'll see. So I have a UML diagram here, about as simply object-oriented UML as possible. In fact, there aren't even any classes or objects in this. So what we know from UML, and again, I have a whole series on UML, object-oriented UML, and what we see here is a activity diagram. There are no class diagrams, again. It's one simple activity diagram, and in the name of it, it is not something dot something. So there's no classes involved. This is the name of some activity that's just going to happen. This is our big bang, if you will, that starts off program execution, because our operating systems are not object-oriented typically, so therefore it's up to us to create the first object, and we have to have some way of doing that in a non-object-oriented sense. Okay. Again, if there's any questions on that, I've got another series on UML beginning and PowerShell and all that. So we have this system activity here. We start here. The first thing it does is it says it's a lie is assigned true. And so it's a lie, some name that's made up. The computer would have no idea what it is. True, on the other hand, is a built-in keyword in most languages. Most languages will understand true and false as Boolean values of a Boolean type. And then we have our assignment operator. So we're making up this name, it's a lie, and we are assigning it the value of true. Again, all of those things should make sense. The assignment operator, that is not an equal sign, Boolean values, identifiers should all make sense. If not, see my UML series on that. And then we have another name that's made up, capacity. We just have to kind of know that that's not a keyword in most computer languages. Most computer languages have 30 or so keywords in them. We'll get to recognize them over time. And it is also not a literal value. Because there are no quotation marks around it. It's not a literal string, and it's not a number like the 12 that can be interpreted as a literal number 12. So we're making up some name, capacity here. That's going to be the name for some memory address. All of this data has to be in memory someplace. So the machine is going to pick some place in its brain and its memory and say, okay, I'll recognize that place by the name of capacity. And then it's going to assign or stick the value of 12 in that memory location. So anytime we refer to capacity, we are referring to the value of 12 that is stored there. Okay, and then we go on to say that course, again, another name that I'm making up here, is assigned the literal string CSCS 1240. And here we notice that because that CSCS 1240 is on the right-hand side of the assignment operator, and it is in quotation marks, makes it a literal string. The other thing that I'm doing here is, and I make a note here, under the assumption that most languages understand the basic native types of Booleans, numbers, and strings. String being a sequence of characters, number, any number, and in UML we don't want to be bogged down into, how many bits are there for that number. In fact, don't even really care usually whether it's a floating point value or an integer value or whatever. More to come on that in a moment. So I see this code over here, and I've got some notes, and I'll follow the same format. So I have some codes over here, and I've actually got two versions of it. One is referred to as weakly typed, and the other is strongly typed. And so again, I'm assuming that coming in here, you have a notion of types and the importance of types from the UML series that we did or some other videos that I've done. But as a refresher, types are critically important for the machine, and the types tell the machine two things. One, how much memory is needed to store a value. How much memory in bits or bytes is needed to store a value of that type. And secondly, how is the memory of that type organized? When we get into more complex types, other than numbers, strings, and booleans, they can be composed of a number of subtypes. And so the organization of those is the other thing that a type tells us. Again, get a little ahead on that. Or it's review from the UML. Okay. So again, because this type thing is so critical, the machine needs to know the types of things so it can stick them in memory, the types of values, so that it can put those into memory. If we don't tell it, it's going to have to figure it out somehow. And we've taught the machine a lot about types, and so the machine is fairly capable in many instances of figuring out, hey, what type should this be? How much memory and how's it organized, kind of thing. But we usually almost always have the ability to say specifically, explicitly, that this is the type that I'm using, and we would refer to that as strongly typing. The other important thing here is between strongly and weakly typed is, as I was saying, the machine absolutely has to know at some point when it's executing what the type of the values are. So it really becomes a question of when in the translation process does it have to know that? If it needs to know the type very early in the translation process, we would say that that language is strongly typed. If it can postpone for a while, maybe right up until execution, as to whether it knows what type the value is, we would refer to that as a weakly typed language. Okay. And another thing about PowerShell that's kind of nice for us is that it understands both. Okay, so PowerShell is a weakly typed language, but we can explicitly say what the types are. So there's some other notes here. Let's see. In PowerShell, variables start with a $sign. So in UML, I can simply say, oh, it's a lie is assigned true. And over here in PowerShell, you're going to see that I'm going to say $sign, it's a lie, is assigned. That's still our assignment operator. That doesn't change. And $sign true, so we see that true is a built-in variable in PowerShell. And then I'm saying $sign capacity, that's my capacity value, is assigned the literal number 12. PowerShell understands literal numbers in decimal, that's important. And then finally I'm saying $sign course, so that's my course variable, is being assigned the literal string CSCS 1240, literal strings in quotes. Again, that's pretty common in most languages. For the strongly typed versions then, I am putting the type before the variable name. So when I'm making a declaration, when I'm declaring that, hey, it's a lie, is a variable now, it's a lie thing exists, I put the type in square brackets in front of it, before it, to the left of it. So I'm saying that, okay, I'm specifically stating that it's a lie is a Boolean type of value, and then I assign it $sign true. For capacity, PowerShell does have a number class, a number type in there, but we typically don't use it. And this is true for many, many languages. Many of the C-based languages are this way, where there is a number type. Python, Java, for example, have this number type. C, C++ don't, typically. But the implementer has to worry about, oh, how many bits and bytes are there used for this kind of thing? Is it floating point or an integer value? Stuff that, again, in UML, I don't want to be bogged down with that. I'm going to leave that up to an implementer who should know what they're doing to say, oh, okay, I can look at this model and determine that this value is only, the value of course is only ever an integer. So I'll make it an integer. Or maybe it's a floating point value. Okay, so double is a type of floating point value. It's a double precision, meaning it's using twice as much memory as a single precision value would be. And some languages have a single type. Others just have a float. Because that was the first thing that came along, and everybody just dealt with floats, and that was cool. But then when we needed more precision, we came up with a type that would use twice as much storage, and have more precision on it. I'll leave it at that for the moment. And then chorus is a string. And so the other thing we'll notice from this is that back to that idea of in a weakly typed environment, the translation machine would do exactly what you and I would do and look at this and say, oh, if it's being assigned a variable, if it's being assigned a value of $true or $false, then those are Boolean values, so this should be of a Boolean type. It would probably look at this and say, oh, okay, if you're assigning a value of 12, then I'll make this an integer type. And since all integers are floating point values, but not all floating point values are integers, I'm going to err on the side of caution here and say I'm going to assign it a double. And then, again, when it looks at the right-hand side of the assignment and says, oh, you are trying to assign a literal string to this, well, I'll make it a string type.